These are some difficult questions. I will call them level 2 questions to find the number of real roots. Well, if you have not taken the test number 1 before this, I'll advise you to go through the test number 1 questions and then come to this. Okay. Now here the question is, find the values of k such that f of x equals to 4x squared plus kx plus 2 has equal real roots, right? We are not directly saying it has one root, two root, or no roots. We are trying to say has equal real roots. It means what? It means always a quadratic function will have two roots. Now here when we say equal real roots, that means both the roots are, first thing, real, second, they are not distinct, they are same. Do you understand? So sometimes we use the word distinct roots. Distinct means separate roots. Equal real roots means exactly one root. So think that this problem says find the values of k such that f of x equals to 4x squared plus kx plus 2 has only one root. That makes sense, right? So that means it should be a perfect square, right? Then the parabola will be on the line and you get one root, right? So once you understand the problem, it becomes much simpler. And let me now show you what I'm trying to say, that if you have a function here, then it will have one root if your vertex is on x-axis, correct? Parabola is opening upwards, and that's why I'm taking this kind of an example. If it has two roots, then the vertex is somewhere below x-axis, and if it has no roots, then the vertex is over the x-axis, correct? So that is what our thinking is. Now we have to find different values of k which can give the vertex right on the x-axis, correct? Well, now we could do perfect square, completing the squares, but the best way to do is our old method of finding discriminant, right? So let me first write down what a discriminant is. As you already know by now, discriminant is b square minus 4ac, correct? So we are always trying to find the value of b square minus 4ac. If it is negative, then we don't have any real solution. If it is 0, then we have one real solution. And if it is positive, we have two real solution, or two real roots, or two x-intercepts, okay? Now, here has equal roots means one root, correct? So we want to equate this to just 0 to find that particular answer, correct? So let's now start doing it. So what we will do is we will find b squared minus 4ac for this. Now what is b for you? B is k, and a is 4 and c is 2, right? So we say discriminant d equals to b squared minus 4ac. I'm not writing b squared minus 4ac. I'm just saying b is k, so it is k squared minus 4 times a is 4 and c is 2 times 2, correct? So that's our discriminant. So we can solve for this as k squared minus 4 and 4, 16 times 2, 32, right? We can write like this also. It is a better way of writing, but anyway, we'll write 32. Correct. And for it to have equal real roots, discriminant should be 0. So we'll write 0 should be equals to this. Is that okay? Now, therefore, we'll solve for k squared from here. So we'll bring 32 this side. So it's 32 equals to k squared, right? So what is equals to, what is k then? K is plus minus square root of 32 equals to k. Now, radical. How are you going to solve the radical? So radical can be solved like this, as you know. Now k equals to plus minus square root of 32 can be written as 4 times 4 times 2, right? 16 times 2, correct? So let me write this as 16 times 2, right? And in the radical, this is a perfect square of 4. So this 4 can be taken out and we get 4 square root 2. Do you see that? Therefore, k is plus minus 4 square root 2. And for that value of k, we should get exactly one root. Do you understand? So there are two possibilities. So therefore, k equals to plus minus 4 square root 2. for having two distinct roots, right? So k could be 4 square root 2 on this side and on this side. So the possibilities are we could have either this kind of a graph, right? Or we could have this kind of a graph, right? Both will give you one root, and this point is minus 4 square root 2 and this point is plus 4 square root 2. Do you understand? That is how the problem is solved, and this I am drawing two different situations which will yield our result. Okay, I hope you understand the concept and appreciate. I also appreciate this part that it was not really necessary to expand it. It really helps you in radicals to write it in factored form. So I'll suggest not to use calculator so many times. You can use it like this. Multiply when required. Next question. Find the values of k such that f of x equals to kx squared minus 8x plus k has complex roots. Now, complex roots means that within the radical we get negative thing, right? So the radical is less than 0. So that is what is meaning of complex roots. Complex roots means that b square minus 4ac is less than 0. Then you get complex roots, not real. This is the meaning of this question, correct? So we'll again go ahead with our calculation as we did last time, and we'll find the discriminant d equals to b square minus 4ac. So b is minus 8. So minus 8 square is 64. Minus 4 times a is k and c is k. Correct. Now we want this to be d less than 0, correct? Or this number to be negative. Does it make sense? Yes. So discriminant should be less than 0, or we will say that 0 is greater than this number, right? 64 minus 4k square. Is it okay? I can factor out 4 from here. I can write 0 is greater than, I can factor out 4, right? 4. And what do I get? 4 divided by 64, 4 times 1 is 4, and then 24, 4 times 6 is 24, minus k square. Is it okay? Now, this can be written as 0 is greater than this. Let me solve it here for you. I want to use different thing because it confuses you. Let me break it down first, right? And let's take on to this place. So we say 0 is greater than, or this is less than. I'll write this in factored form. 4 times 4 minus k. This is difference of square. 4 square minus k square, correct? Times 4 plus k, correct? Do you remember difference of squares? A square minus b square is a plus b times a minus b, correct? Now here I'll show you two different ways of solving it. One by graphing. So let's say we have a small graph here, and if you want to graph this equation, then k, let's say the variable is k for us. So 4 and 4, so k is 0 when you have plus or minus 4. So we have a 0 here at 4 and another one is here. What's the coefficient of k? Minus k square, so minus. So that means it is opening downwards, correct? So we have a graph this time of k which is opening like downward like this, right? Kind of like this. You will see that within this region it is positive and beyond this region it is negative, right? So if you want that this should be less than 0, then we are looking for a solution which is on this side. Do you get that part? So it is negative when either the value of k is greater than 4 or it is less than minus 4. Do you see that? So this point is minus 4 for us and this point is plus 4 for us, correct? You can also test the values. For example, what I will do is I will test the value of my function. So let me show you that method of testing values now. What we will do is we can have, with these two zeros, I have got 3 different planes, right? We have divided this plane into 3 parts. So we'll have a test value. Let's say we test number 0 here. 0 is in between this region, right? And in this region, we can have a number minus 5, and here we can have a number plus 5, correct? Now, if I put 0 here, then what happens? So this is our function fx, right? Let's say we write f of x, correct? Now, we will test this for value minus 5 for 0 and plus 5, right? If I write minus 5 for k, then 4 minus 5 becomes positive, right? But this becomes negative. 4 minus 5 is negative 1. So we get a negative number here, right? That is what I'm trying to say. If I put this k as 0, right? Well, 0 means 4 times 4, 16. Let me try another number in between. Let's say minus 1, okay? So if I put this as minus 1, then 4 minus 1 makes 4 plus 1, right? Which is positive. And 4 minus 1 is also positive. So it remains positive. Do you see that? If you try plus 1, then it is 4 minus 1 is 3 and 4 plus 1 is 5, even then it is positive. Is it okay? Now if you try a value of plus 5, then 4 minus 5 is negative, but 4 plus 5 is positive. Positive times negative should be negative. Therefore, in these two regions, we have this function less than 0. Do you understand? It's negative, correct? And therefore, what is our answer? To get complex roots, the answer is that k should be either less than minus 4 or k should be greater than plus 4. Do you understand? It's a very complicated problem. You will understand better once you do inequalities also, right? But in any case, I've tried to show you the concepts of inequality here using factored form and the table, and also shown you with the help of a graph, right? So probably you get it. If not, you may look into the chapter on inequalities and how to solve them and come back to this, correct? Okay. Now the third problem is huge. Now, I'm not going to solve the third problem because there are only two complicated problems done for you. Third problem I'll read out for you. It says, the graph of a quadratic function f of x equals to ax squared plus bx plus 1 pass through point 1, 2. For what values of a does the graph intersect x-axis at two distinct points? Now, first, what do you really understand from this question? Does it make sense to you? It's too complicated. Let's again read it. The graph of quadratic function f of x equals to ax squared plus bx plus 1 pass through point 1 and 2. X is 1, y is 2. So it is on this graph. I can always plug 1 here and get the value of f of x. For what values of a does the graph intersect x-axis at two distinct points? So instead of k, we are using a, and to get this variable, we can use this point and write b in terms of a. This is one thing which we get from it, okay? So here for this question today, I'm only giving you a hint. So first thing is use this point. So f of 1 is what? So we say f of 1 equals, we'll plug in 1 here for x, and we get a plus b plus 1. And what is f of 1? The value of function at 1 is 2, so we can write this as 2. Is it okay? Now this gives me a relation of b in terms of a. So from here, I can write what is b equals to? B equals to 2 minus a minus 1, right? So 2 minus 1 is 1. So it is 1 minus a. Correct? So that is b. Now we got a b value here. We'll change the equation and write in terms of just one variable, and that variable will be a. Okay? So we'll write again now f of x equals to ax squared plus, instead of b, I'm writing 1 minus a. X plus 1. Now that is a familiar equation, right? Like we were doing with k, correct? Now we have only one variable, and now read the question. For what values of a does the graph intersect x-axis at two distinct points? Two separate, not same. Two real roots, that means. Do you understand? Two distinct points. So now b square minus 4ac should be how much? Because we want two distinct points, we should have b square minus 4ac greater than 0, right? So what is b? B is this, a and c. Now it should not be very difficult for you. But in any case, try it on your own. I'm telling you, it's not just the same as we did last time. But remember how to solve for x-intercept. You may not get directly from a standard form. From standard form of equation, you cannot find x-intercept so easily. You may use quadratic formula to do it, right? Okay. Or you may do completing the squares, okay? And then get vertex form there you can use, right? So if you want, you can go through those videos which are on calculating or finding x-intercepts from vertex form and then completing the squares to write the equation vertex form. Okay, I think that should help. Now try these questions. If you have difficulty or any suggestions, do make them. If you like the comment, you can like it and put your comments there. And if there are more problems for me, send them over. I'll be more than happy to solve it. Thank you.